Welcome to This Explainer. Today, we're going to fundamentally challenge literally everything you thought you knew about how human knowledge actually progresses. I mean, we all tend to take for granted that the scientific facts we learned in school represent this absolute unchanging reality, right? But what if the very foundation of how we build scientific knowledge is completely different than what we've been led to believe? Think back to your earliest science classes. We're typically taught that science is this straight, upward line of accumulating facts. It's presented like this grand, collaborative project, where each generation of researchers just adds a new brick to an ever-growing tower of undeniable truths. But is that actually the case? If we really dig into the history of scientific discovery, does it actually reflect this neat, orderly construction project?
Well, let's dive into it. While the classic textbook view implies that science is just a steady, piecemeal accumulation of knowledge, an ever-growing stockpile of facts and theories, digging into the historical record reveals a completely different, totally nonlinear reality. The textbook image of science is highly curated. It's designed to be persuasive and pedagogic. It's kind of like a tourist brochure trying to define an entire national culture. It simply doesn't fit the actual enterprise that historically produced those scientific achievements in the first place.
Let's start by looking at a physicist's accidental discovery.
To really understand this disconnect, we need to talk about Thomas S. Kuhn. Now, he wasn't initially a historian or a philosopher. He was actually a theoretical physicist. As a grad student in physics, with the end of his dissertation already in sight, Kuhn had this fortunate involvement in an experimental college course. Basically, he was tasked with teaching physical science to non-scientists. And this assignment gave Kuhn his very first deep dive into the actual history of science. Instead of just looking at the finished, polished formulas of modern physics, he started reading about how ancient and classical scientists actually thought and worked. And wow, this sparked a drastic shift in his entire career, moving him away from physics and straight into the history and philosophy of science.
Kuhn had a profound reaction to this historical deep dive. He wrote, "To my complete surprise, that exposure to out-of-date scientific theory and practice radically undermined some of my basic conceptions about the nature of science." He realized that the out-of-date beliefs he was studying just didn't fit the neat, cumulative enterprise that standard science education portrays. He saw that the concepts he'd drawn from his own rigorous scientific training simply failed to match historical reality. The history of science wasn't just some graveyard of mere errors and superstitions. It was a record of entirely different, fully functioning ways of understanding the world. Which brings us to the historiographic revolution. Kuhn's personal realization actually mirrored a much larger revolution in the study of science. Historians who were acting as mere chroniclers of an incremental process found themselves hitting a massive wall. They discovered that as they did more research, it became harder, not easier, to answer seemingly simple questions. For example, exactly when was oxygen discovered and by whom? Who first conceived of energy conservation? Plus, they found it practically impossible to strip away past superstitions from the so-called scientific components of older beliefs. They started to suspect that asking for exact dates of discoveries was just the wrong sort of question to ask. You actually have to study the history of science in its own time, within its own historical integrity.
The shocking truth that emerged from this research is that discarded theories, things like Aristotelian dynamics or phlogistic chemistry, were just as scientific in their time as our theories are today. They were neither less scientific nor more the product of human idiosyncrasy than the ideas we hold right now. The scientists of the past weren't less intelligent, and their methods weren't necessarily less rigorous. They were simply operating within a completely different framework of understanding. They were just trying to make sense of the universe using the best tools and conceptual boxes they had available at the time.
So, here's the crucial dilemma this creates for us today. Think about it. If we look back at these old, out-of-date beliefs and call them myths, well, then we're forced to admit that myths can be produced by the exact same sorts of methods and held for the same sorts of reasons that lead to modern scientific knowledge. But on the other hand, if we call those old beliefs science, then we must admit that science has historically included bodies of belief that are utterly incompatible with the ones we hold today. Either way, the whole idea of science as a steady accumulation of permanent truths just totally falls apart.
So how does this all work? Let's talk about nature in conceptual boxes.
If science isn't just a growing pile of indisputable facts, how does a scientific community ever agree on anything? Like, how does research actually get done if everything isn't just building blocks? Well, Kuhn noticed a stark difference during a year he spent at a research center surrounded by social scientists. He observed that natural scientists, like physicists, chemists, and astronomers, generally share a unified foundation. They aren't constantly debating what constitutes a legitimate scientific problem. But among social scientists, like psychologists or sociologists, there are endemic, ongoing controversies over the very fundamentals and methods of their fields. The natural scientists seem to have something the social scientists lacked, something that allowed them to bypass those foundational arguments and get straight to the highly detailed work.
And this brings us to Kuhn's most famous concept, a real game changer, the paradigm. The secret ingredient of natural science is this paradigm. It's basically a universally recognized scientific achievement that, for a period of time, provides model problems and solutions to a community of practitioners. It acts as the shared foundation. Once a scientific community adopts a paradigm, they just stop arguing over the basics and start working together within that shared framework.
A scientific community absolutely relies on this paradigm to establish firm answers to the really big fundamental questions. What are the basic entities of the universe? How do they interact with each other? What questions are we even allowed to ask about them? And what mathematical or experimental techniques are we supposed to use? These answers aren't just suggested, by the way. They are embedded deeply and rigidly through professional education. When you study to become a physicist, you are quite literally being indoctrinated into the current paradigm.
Kuhn brilliantly describes the everyday, day-to-day research that scientists do within this framework as normal science, and he defines it in a very provocative way. He says normal science is a strenuous and devoted attempt to force the complex realities of nature into the rigid conceptual boxes supplied by that professional education. Scientists spend almost all their time doing exactly this. They assume they already know what the world is fundamentally like, and they dedicate their entire careers to making the observed facts fit perfectly into their paradigm's boxes.
But what happens when things don't fit? Let's explore the path to revolutions.
Seriously, what happens when nature absolutely refuses to fit inside these established boxes? Well, because normal science rigidly assumes it already knows what reality is, it actually often suppresses fundamental novelties. New weird discoveries are seen as subversive to the basic commitments of the community. But eventually, a problem, one that really ought to be easily solvable by the known rules, resists the reiterated onslaught of the ablest minds in the field. Despite their absolute best efforts to force that stubborn fact into the conceptual box, it just won't fit. And this is when an anomaly emerges.
In fact, Kuhn dedicates a whole chapter to this, titled Anomaly and the Emergence of Scientific Discoveries. This failure to make an anomaly conform to the existing rules is what directly triggers a massive crisis in the scientific community. It's a period of deep professional insecurity. The tools that have worked for generations suddenly stop working. The paradigm begins to blur, and the community realizes that their foundational map of reality basically has a massive tear in it.
And that brings us to the nature and necessity of scientific revolutions. This unavoidable crisis eventually forces the community to abandon their old conceptual box entirely. They can't just add the new anomaly to the old pile of facts, because the anomaly literally breaks the pile. They have to adopt a completely new paradigm, an entirely new way of seeing the world. This is a rule-breaking, scientific revolution. It's a disruptive shift, much like a political revolution, where the old regime is overthrown and replaced by a brand new framework that can finally accommodate the anomaly.
Understanding this changes absolutely everything about how we view human knowledge. If science progresses through these disruptive, revolutionary shifts rather than a steady, peaceful accumulation of absolute facts, we are left with a pretty profound realization. The theories and laws we hold today as absolute truths, they aren't the final endpoint of human understanding. They are simply our current paradigm. And so, we have to ask ourselves, what anomalies are currently being suppressed in our own scientific communities today, and what modern truths will be the next to completely shatter? Thanks so much for joining this explainer, and remember to keep questioning the boxes you view the world through.